Hi guys! So sa previous video natin, diniscuss natin yung mga formulas involved pagdating sa shearing stress. So sa ngayon, apply naman natin siya using this example problem number 1. So determine the shear stress in the 20 mm diameter pin at A and the 30 mm diameter pin at B that supports the beam in the figure. Okay. So drawing natin siya, class. So at A, pin connected siya. At B, pin connected din sa cable. So ganyan. Okay, tapos merong loading na 30. Ano pa? Given in diameter at A. Diameter at B, 30. And then yung slope ng cable, 345. Okay, so your question is shear stress at A and then shear stress at B. So para makuha natin yung mga shear stresses na yan, kailangan malaman natin yung shearing force at A and also area at A, and then shearing force at B, and then yung diameter area at B. So yung area madali na given yung diameter. So para makuha yung mga shearing forces, edi palabasin natin yung mga support reaction. So at A, okay, so downward load. So definitely itong A magbibigay siya ng upward reaction, AB, upward component, and then horizontal component na AH. Okay, so therefore andi dito yung total resultant or total reaction at A. Tawagin ko siyang RA. Okay, reaction at A. Okay, so paano mapapalabas yung mga, kasi hinahanap natin yung shear stress at A. So kailangan makuha ito mga support reaction at A. So para magawa ko yung class, siguro maganda dyan class, ikat ko tong cable. Puputulin ko yung cable and then consider ko itong figure sa baba. So mangyayari dito, magkakaroon ng reaction yung cable, no, na tension. Tawagin ko itong force sa cable BC. Okay, force sa cable BC. So ngayon class, para makuha itong mga support reaction at A, magte-take ako ng summation of moment at B. So by taking summation of moment at B equals 0, considering clockwise moments positive, so that walang dimension, so 2 saka 4. So AB moment arm is 6 and then 30 moment arm is 4 equals 0. So solving for AB now equals 20. Okay, next kailangan ko tong AH. So paano kukunin tong AH? So kunin ko muna tong PBC, no? So by taking summation of forces vertical equals 0, considering upward forces positive, so that AB minus 30 and then plus vertical component neto, so that is 4/5 of PBC equals 0. So AB is 20. So now PBC equals 12.5. Okay, PBC na ako, may AB na ako, so masagot ko na tong AH. So by taking summation of forces, horizontal naman equals 0, considering forces to the right positive, so that negative AH, and then itong horizontal component, so that plus 3/5 naman ng PBC equals 0. So negative AH plus 3/5 na 12.5 equals 0. So ilan ang AH naman? AH equals 7.5 kilonewtons. So masasolve ko na class yung reaction at A using yung mga values na yan. Okay. So that reaction at A equals the square root of AB squared plus AH squared. RA AB is 20 squared plus AH, so ito yan, 7.5 squared. RA now equals so that's 21.36 kilonewtons. Okay, so for stress at A, no, P at A, meron na akong shearing force at A. So ito na yung shearing force at A. Ngayon, ilan ba yung anong type ba ng sheared area yung meron? So that ano ba yan, single shear ba yan, double shear, or punching shear? So tingnan natin yung diagram na provide. So at A, ito yung connection detail, no. So pag ganito siya. Okay, ito yung member, tapos andito yung andito yung pin. Ito yung A. So ito yung pin, ito yung member, no. Ngayon, meron dito nag-exist na yun na yung RA na. Yung shearing force natin, yung RA. Ngayon, para matanggal natin tong left member dun sa yung support dun sa member, paano ilan yung area na puputulin natin, class? Hindi kailangan maputol siya dito, tapos maputol din siya dito. So therefore, ito pala is under ng double shear. Okay? So anyways, yung formula lang naman ng stress, diba, is force over area. So ngayon, ilan ba yung total force? Di yun yung RA. Ilan ba yung total area being sheared? So dalawang area, diba? Area nito sa area nito. So that is, so lagay ko to, shearing force, sheared area. So yung total area is dalawang area nung pin. Okay, so solving for stress at A, so that is equal sa RA 21.36, so gawin ko 21,360 newtons divided by dalawang area ng pin at A. So si A, diameter niya is 20, that is 2 times pi over 4, and then 20 squared, and then unit is mm squared. Okay, so Newton per mm squared still MPa. So ilan ang stress or shearing stress at A? So sagot is 33.9955. So that is 34.00 MPa. Okay. And the next, ang tinatanong naman class is yung shear stress at B. So para makuha yung shear stress at B, di kailangan ko na itong PBC, no? Siya na yung magbibigay ng shearing force doon sa pin dito sa B. So ito na yung shearing force at B. So for tau B, so that is ba yung connection na meron sa B. So sa figure makikita mo, class, ito naman yung connection detail at B, di ba? So ito yung cable, tapos connected siya dun sa member by a pin. Ito yung pin. So, ito yung B na figure. So, nakita natin class sa cable, meron ditong force na PBC. Okay. So, ngayon, syempre dito, PBC na rin yan. Anyway, so para maputol natin yung cable, mahiwalay natin yung cable dun sa member, ilang area yung puputulin dito naman, class? Ilang area yan, class? Di, isa lang, di ba? Kailangan dito maputol siya. So, therefore, this one is under naman na single shear. Isang area lang yung kailangan maputol para mahiwalay natin yung dalawang member. So anyway, so that's shear stress at B is equal sa shearing force over the sheared area. So yung shearing force dito is yung PBC, while yung sheared area is yung one area lang ng pin. Okay, so that PBC, nasolve natin yung kanina, ito yan, 12.5, so that is 12,500 newtons over the area ng pin at B. So ito naman siya, 30 mm. Is pi over 4 times 30 squared, and the unit is mm squared. So that's shear stress at B now equals. So sagot 17.68. Unit is MPa. Okay, so yun na siya. Okay, ano yung important lang dito, class? Malaman mo kung ano yung mga forces or yung kung ano yung shearing force, at the same time kung ilan yung area being sheared. And then formula is simply as shearing force over the sheared area. Okay, let's check kung tama yung sagot. So 34 and then 17.68. Okay, next. Ayan. Anong sabi? Okay, so sabi dito, the bell crank, which is in equilibrium under the forces shown in the figure, is supported by 20 mm diameter at pin at D that is in double shear. Determine A, the required diameter of the connecting rod AB, given that its tensile working stress is 100 MPa, and B, the shear stress in the pin. Okay, so drawing muna natin, class. Ito yung rod AB. And then, dito yung isa pa. So, C, D. So, ngayon, yung rod AB subjected sa force P. And then, itong sa C, 30 kilonewtons. So, given yung angle, 60. It's 240. This one is 200. Okay, ano pa yung mga given, class? So, given 20 mm diameter pin at D. So, diameter at D equals 20 mm. And then, so mga required, class, una, yung diameter at AB. But, given yung tensile working stress. So, pag sabi natin tensile stress, di ba, under yung normal stresses. So, given daw yung allowable normal stress, or allowable tensile stress at rod AB is hanggang 100 MPa. Okay, and then next na record is yung shear stress at pin at D. So, tau D. Okay, so unahin natin, class, yung AB. So, 4 diameter AB, yung diameter na itong rod na to, para makuha yung diameter niyan, so given yung allowable normal, walang force P, so kailangan kong kunin yung force P. Tama ba? So pag may force P na ako, may allowable, kaya ako nasunod kunin to yung diameter. Kaso paano kukunin yung force P? So ano bang sabi dito, class? So sabi dito ay mahalagang sinabi, the bell crank, which is in equilibrium under the forces. So ibig sabihin pala, class, dapat masatisfy na itong figure na ito yung 3 equations of equilibrium. Anyways, palabasin na natin yung mga support reaction. So sa D, meron ditong vertical component, DB, and then horizontal component, DH. And then, dito yung resultant ng dalawa. So, tawagin ko siyang RD. So, sabi, yung 4 forces na to, na makikita mo, dapat masatisfy niya yung 3 equations of equilibrium. Ngayon, paano natin solve yung force P? So, tatlo yung unknown. So, siguro maganda, ma-eliminate ko itong dalawang mag-take na lang ako ng summation of moment at D equals 0. So, for AB, so by taking summation of moment at D is equal to 0, considering clockwise moments positive. So, itong P at D, so counterclockwise siya with the moment arm of 200. So, negative P times 200. And then, itong 30, so yung moment arm niya at D, so yung perpendicular. So, ito yun, kaso mahirap, diba? So, ang gagawin natin is, kunin na lang natin yung components nito, 30. So, 30, vertical component is 30 sine 60. Yung horizontal component niya is 30 cosine of 60. And then, ayun, at D, so ito walang moment arm. Ito may moment arm na 240. So, clockwise ito, so plus. So, plus 30 sine 60. Moment arm is 240 equals 0. So, that P now equals so, sagot is 31.1769 kilonewtons. So, pag may force P na tayo, masolve na natin itong diameter using yung allowable, normal, or tensile stress. So, stress at AB is equal sa PAB over area ng AB. Okay, so ito given 100 MPa. Itong PAB na-solve na natin, 31.1769. So, gawin na natin Newton. So, 31.176.9 Newtons divided by required area. So, that is pi over 4 times the diameter squared. Okay. So, ilan yung diameter? Or, gawin ko tong symbol na diameter na ginamit ko dito. Diameter AB. So, the diameter AB now equals so, sagot 19.92 mm. Okay. So, next. Shear stress naman at dito. So, para makuha yung shear stress dito, kailangan ko yung shearing force, which is itong RD, and then yung area being sheared. Makukuha yung area being sheared using yung diameter. So, ang goal ko class kunin yung RD. So, para makuha yung RD, kunin ko yung mga components. So, unahin ko itong vertical component. So, by taking summation of forces vertical equals 0, considering upward forces positive. So, that ito, vertical dB, and then vertical negative 30 sine 60 equals 0. So, that dB now equals so, sagot is 25.98 kilonewtons. Then, by taking summation of force horizontal equals 0, considering force to the right positive. So, negative P, positive DH, and then negative 30 cosine of 60 equals 0. Pero meron na tayong P, diba? Yung nasolve natin kanina. Ito, 31. So, negative 31.1769 plus horizontal component minus 30 cosine of 60 equals 0. So, that DH now equals so, sagot 46.1769 kilonewtons. Okay, so meron na akong dB saka dH, so kaya ko nang solve yung reaction, yung resultant. So that RD equals the square root of dB squared plus dH squared. So that RD equals plus 46.1769 squared. Then ito. So ito is 52.984 kilonewtons. Okay, so meron na akong resultant or reaction at D. So kailangan ko na masosolve ko na ngayon yung tau. So para masolve yung stress, equal ulit saan? Or sa shearing stress, no? Ilan yung shearing stress? The shearing force over the sheared area. Okay? So para sa shearing force, edi na yung etong resultant force at D, yung reaction at D. Okay, paano naman tong sheared area? So anong sabi dito class? Di ba binigay class yung yung figure. Okay, at sinabi rin naman class na double shear siya. Okay, anyway, so i-analyze natin para mas magets ulit. So ito yung support at D. Ito yung member, di ba? So ito yung pin. So dito may nag-exist dito yung reaction RD. So syempre ganoon na rin dito. So ngayon para makalas natin yung member na yan, anong gagawin class? Eh di kailangan maputol yung pin. So saan siya mapuputol class? Dito saka dito. Kaya nga siya sinawag na double shear. So therefore, kung double shear siya, so papalitan ko tong sheared area over shearing force over sheared area. So shearing force yung RD, while the sheared area yun yung twice the cross-sectional area nitong pin. So now, shear stress at D equals RD. So yung 52. So convert ko na to class. 52.984 newtons over twice the area, 2 times yung area niya. So given diameter is 20, so that is pi over 4 times 20 squared, and then unit is mm squared. So now shear stress at D equals so sagot is 84.33. Unit is Newton. Okay, hindi pala nakikita. Unit is Newton and then mm squared, so that is MPa. Okay. So check natin class kung tama yung sagot. So area 19.92. And then ayun, tama. Okay, next. So next, what force is required to punch a 20 mm diameter hole in a plate that is 25 mm thick? The shear strength of the plate is 350 meganewton per meter squared. Okay, so for number 3, so let's say ito yung yung pang-punch niya. Okay, and then anong sabi class? Ito daw is 20 mm. Okay, and then ito let's say yung yung plate. So sabi dito this plate is 25 mm thick. And then binigay daw yung shear strength ng plate. So itong plate na to meron siyang shear strength. So tau allowable yun class, no? T ng plate is equal sa 350 mega Newton per meter squared. So class, di ba ito Newton per meter squared, naalala mo ba yan class? Di ba ano yan? Pascal. So ibig sabihin, pwede ko rin itong i-write as 350 mega Pascal. Okay, so yun. T-plate. So para makuha yung class, simple lang. So solution, edi yung formula lang ng shear stress, no? That tau is equal sa the shearing force over the sheared area. So di ba dito lalagay yung force P. Okay, ngayon para mabutas to, ano nga ulit yung gagawin dito class? So para mabutas to, let's say ito yung hanggang sa thickness T pa, so ganyan yan. Okay. So di ba yung sheared area dyan class is yung itong nakapalibot. Diba? Nagawa na natin yan last time, diba? So, itong palibot na to pati yung sa likod, yun yung sheared area. So, that is itong PS, yung P dun sa taas. So, yan P. And then yung area nito, it is circumference times the thickness, or circumference is pi d. And then yung height is thickness. Okay, ngayon, binigay ito. Tau. So that's 350 MPa equals yung force P hinahanap, and then pi, and then anong diameter 20 mm, and then yung thickness is 25 mm. Okay, so megapascal, mm. So P na mas-solve dito must be in Newton. So P now equals, so sagot is 549,778.71 Newton, or in kilonewton, that is 549.78 kilonewton. Sobrang laki ng bali, kaya palitin natin yung unit. Okay. So ayan, so check natin class kung tama yung sagot. 549.78. So class, hanggang dyan na lang muna tayo class. So yung next problems na natitira, solve natin sa next video. So thank you and God bless.